Our second lecture in Unit 7 on workflow interoperability affords practice in workflow and process improvement as it relates to value-based care. The case studies presented in the first lecture for Unit 7 were real-life examples, but generally were confined to improvement opportunities in hospitals and clinics and focused on one process in each setting. In this lecture, our practice case studies will look again at one of these from a broader perspective of transitioning across departments, but the remainder of the case studies will look at transitions across entities. This lecture will also be a bit different than previous lectures. We're going to start off bringing back 3 of the slides from the first lecture as a reminder of what we talked about and for you to have handy should you need them as references as we proceed through the case studies. Then for each case study, we're going to give you a narrative description of a process and workflow, and then ask a series of questions related to workflow interoperability. We'll pause briefly after each question for you to consider your answer. You might want to pause the lecture at these points to write them down. At the conclusion of each case study, we'll supply some potential answers, which may include suggestions that further exploration is needed to truly come up with a proposed solution for something. Remember, there are not necessarily absolute right or wrong answers. One size does not fit all in process and workflow. However, we are seeking interoperability here, so the more our answers align, the better off we are. We noted in the last lecture that there are a variety of mapping tools that can be used to perform workflow and process mapping. Process diagrams are used where the focus is on materials and people with few handoffs. They are the least commonly used tool in healthcare workflow and process improvement. Swim lane process charts may use the same symbols as the process diagram or the system's flowchart and permits the arrangement of steps into rows that describe who or what department or entity performs various tasks in the process. Flow process chart incorporates process diagram symbols, measurement of units of work, time, and other factors, and may be the easiest to use for those who prefer narrative descriptions over pictures. Systems flow chart is the most common tool used in process mapping today and can be as simple even as with using sticky notes or as complex as desired. It is the best tool for illustrating decision points. Let's remind ourselves about the mapping symbols. In systems flowcharts, or value stream maps as they may be called, the 3 key symbols to use include ovals, which designate starting and ending points that define the boundaries of the process being mapped. Rectangles explain the action steps in the process. Each action step should include 3 elements: who by credential, does, which should be an action verb, and what with as much description as will fit in the symbol. Diamonds designate decision points, which must at a minimum have 2 branches, such as for yes or no and many others, and there can be multiple branches. Root cause tools help get a better understanding of why there is an issue in a process and its workflow. A variety of tools can be used to help determine root cause. Statistical charts, such as radar charts, as shown in the upper right corner of this slide, show the size of gaps among performance areas. The illustration includes 3 key performance areas denoted as red, yellow, and green lines. The lines closest to the outer boundary are the strongest. So the red area, which reaches the outermost boundary, is considered the strongest area of performance in this chart, and the yellow and green areas, which are nearly the same distance from the outermost boundary, are considered the weakest areas of performance. Pareto charts are another statistical chart widely used in workflow and process improvement. It's illustrated in the upper left corner of the examples on this slides and shows how a series of elements may have an effect on a process. Pareto was the economist who first observed the 80-20 rule, in which 80% of most problems stem from 20% of causes. In the chart example here, it appears there are 6 potential factors that could be causing a problem, with the one in red on the left contributing the greatest effect. Not shown, but other common statistical charts include scatter diagrams that can analyze relations using correlation between two variables to determine the likelihood one variable causes the other. Control charts are statistical tools that monitor quality, where a run chart with a center line representing the mean value of the process is used with an upper control limit and lower control limit to monitor where a process has gone out of control. Another type of tool are relations diagrams, such as the fishbone chart shown here in the middle left. They help show cause and effect. An interesting scenario relayed by Bellinger in 2004 highlights the importance in a relations technique called Ask Why 5 times. This was illustrated by a plant manager who finds oil on the floor and first asks the foreman why there is oil on the floor and is told it is due to a leaky gasket. The plant manager second asks why the gasket was not replaced, and the foreman responds that the maintenance department has installed 4 gaskets over the past few weeks and they each leaked. The plant manager third goes to the purchasing manager to ask why the gaskets were bought from a disreputable supplier. And the purchasing manager says they went with the lowest bidder based on direction received from the vice president of finance. The plant manager fourth goes to the vice president of finance and is told, "You indicated we have to be as cost conscious as possible, and this supplier saves us a lot of money." The plant manager then realizes that he was the reason there was oil on the floor and asks himself the 5th question, why he was not more careful in giving directions. This story reminds me of the case study we discussed in the last lecture, wherein the MA was not allowed to document the blood pressure or reason for visit in the chart at the physician office. But it took quite a lot of digging, perhaps 5 questions, to get to the root of why this was occurring. Tree diagrams are not illustrated here, but they use Boolean logic to determine the probability of an event causing harm. They're somewhat similar to the fishbone chart. They can consider independent events, such as a coin toss, or dependent events where one event depends on what happens in a previous event, such as who might win a football game, or the likeliness of an error resulting from a sequence of events. So similar to the fishbone diagram, but with the probabilities identified. The affinity diagram, such as illustrated in the middle right, helps synthesize a large number of ideas by finding relationships between them. We referenced use of this when we talked about analyzing the nursing admission assessment data elements across the 11 forms. One form of affinity diagram is the force field analysis, which helps identify pros and cons of a decision and what may be needed to make an improvement. Force field analysis is also used to motivate people toward a change when they can see that the forces for a change outweigh their efforts to resist a change. So affinity diagrams actually have multiple uses. Finally, physical layouts and movement diagrams are especially helpful when studying physical workflows and where there are opportunities for improvement, as we saw in the last unit lecture.